we have this nice little list here that tells you how to do it. So we have not seen problems like these exactly, because all the ones that we've done have always had what? Nice numbers. There haven't been any fractions, right? So what does it say to do first? Multiply both sides by the denominator. When it says both sides, what's it referring to? Both sides of what?
Everything inside is in parentheses.
Of the equal sign. So here is one side of the equal sign. Here is the other side of the equal sign. What's the denominator? Okay, so in this example, what is that? 3. So if I multiply by 3 here, and I multiply by 3 here, because of what property?
Multiplication property.
Says I have to multiply one side by something and the other side. I can't just pick one side. What happens when I multiply 3 times 2/3? Does anybody know? Let me grab my calculator. By the way, your calculator does have a fraction button that can help you greatly. 3 times 2/3 ends up being 2. So what did multiplying by the denominator do?
Make the fractional number.
Got rid of
Fraction, same thing.
the fraction. So multiplying by the denominator did what to my problem? Got rid of the fraction. So I have a 2. I still have 4x minus 7. And then what do I have on the other side of the equal sign? Negative 15. Is this an easier problem to solve?
Yes.
So I could continue following these steps if I want to, or if I know what to do, I can just do it. Step 2 says, so 2 times 4x is 2 times negative 7 equals what? Okay. Combine like terms if necessary. Do I have any like terms here? Nope. Add or subtract the constant. Which one's the constant? The one with no x. So how do I move the negative 14? Add 14. Oops. So I have 8x equals negative 15 plus 14. Negative 1. By the way, I'm not writing my properties. Shame on me. Distributive property of multiplication right there. And then, let's see, what did I have here? Addition property of equality. I have one more step. What do I do? Divide by 8. Does negative 1 divide by 8 nicely? That's my division property of equality. So I'm going to leave my answer as negative 1 over 8. However, if it's a fraction that can be reduced, I need to reduce it. Negative 1/8 cannot be reduced, so I just leave it as negative 1/8. Easy peasy? Okay, so why don't you try number 1 right here? And if you're feeling especially brave, try number 2. Okay, so what do I need to do first here in number 1? Multiply both sides by the denominator. So here's one side, here's another side. What am I multiplying by? 5. The 5 is going to cancel there because 5 times 3/5 is just 3. And then I have 2x plus 5 equals what? Negative 40. What next? Distribute. What am I distributing? 3 times 2x is, and 3 times 5 is 15. What next? By the way, that was the distributive property of multiplication. This was the multiplication property of equality. What's next? Subtract 15. That's my subtraction property of equality. And 6x equals, what's negative 40 minus 15? Negative 55. And divide both sides by what?
6.
And x equals negative 55 over 6. Can that reduce? Well, you want to see that fraction button on your calculator again? 55, fraction button 6. That is the mixed number. If I hit second and then that fraction button again and enter, that's the most reduced form. So can it reduce?
Yeah.
Nope.
Oh, wait, no.
Negative 55 over 6. By the way, do not give it to me as the mixed number, okay? Mixed numbers you really only use in 3rd grade, and then you don't use them again. You use improper fractions from then on, okay? Yes?
Why don't you multiply negative 8 by 5?
Did I not do that?
Oh.
I did. That's how I got the negative 40. Only thing I didn't do was my division property of equality labeling that one. All right, why is number 2 different? It's the fractions on the opposite side, correct? But I'm still going to multiply both sides by something. But what's different here is this one is negative. Does the negative affect the denominator? It doesn't have to. I can still just multiply by 4 on both sides. So 4 times 7 is 28. Over here, the 4 is going to cancel, and I'm left with negative 1 parentheses 2y plus 3. So what do I do next? Distribute. Negative 1 times 2y and negative 1 times positive 3. All right, what's next? Add the 3. What's 28 plus 3? 31 equals negative 2y. Last step. Divide by negative 2. So y equals, does 31 divide by 2 nicely?
No.
So it's just negative 31 over 2. I'm going to go ahead and fill in my steps. This first one I used the multiplication property of equality. After that I used distributive property of multiplication, addition property of equality, and then division property of equality. We should be pretty familiar with those now, yeah? Okay, because I'm not going to continue to write them. But that doesn't mean the questions about them won't come up. All right, any questions about this stuff right here? How do we get rid of a fraction? Multiply the whole thing, both sides, by the denominator. All right, next one. You've been drinking your milk and taking your vitamins and you feel strong. Apparently you're going to do some bench pressing. The barbell weighs 45 pounds and you load the weights evenly on both sides. Now, has anyone ever bench pressed something like this where you have a bar that you have to, okay? So they're saying that the bar itself weighs 45 pounds. Okay? That's actually a typical weight for a barbell. Okay? Then it says the weights are loaded evenly. So those two sides have the same amount of weight. We don't know how much weight, but it's the same amount. Solve the equation to figure out the total weight you are bench pressing, including the weights and the bar. So, if I know that this weight is the same as this weight, what can I say about those two statements? They're going to be equal to each other. So my equation, I'm going to set up 1/2 times 3x plus 4 equals 2x minus 5, because those are the two weights of the sides of the barbell. Okay. Now, this one's a little different when I'm multiplying by the denominator, because instead of just having one thing on the other side, I have two things on the other side. So as I multiply, notice what I do. What did I just do? I put the whole thing in parentheses. So when I multiply by this denominator, what does that mean I'm going to have to do over here? Distribute. Right? So over here I have 1 parentheses 3x plus 4. And over here I have 4x minus 10. Yeah? Distributing a 1, is that going to do anything? No. So I really just have, I'm going to write it over here so I don't run out of room. 3x plus 4 equals 4x minus 10. Right? Okay, what should I do next? I have x's in 2 different places. What can fix that? Moving one so they're in the same place. Does it matter which way I go? It doesn't matter. One way will give me one less step though. I like moving things so they stay positive. If I want to keep it positive, which one should I move?
3x.
3x. And how am I going to move it?
Subtract 3x.
Subtract 3x. So what's left over here? 4. Bring down my equal sign. What's 4x minus 3x? Minus 10. Is x by itself yet? So what do I do? Add 10. And what does x equal? Okay. So there is the first part of my answer. It says solve for x. I just solved for x. So how much is this person benching? How am I going to find that out? Well, I know that the bar is 45 pounds. Plus, I need to figure out what this side and this side are, right? How do I do that? Plug in x equals 14. So if I plug in 14 here, 2 times 14 minus 5, that's 28 minus 5, that's 23 pounds over there. So 45 plus 23 plus, I got to figure out this side now too, right? 1/2 times 3 times 14 plus 4. What is 3 times 14? 14 and 14 are 28. 42. Plus 4. What's 42 plus 4? And half of 46. Did I really need to figure that out?
No.
Why not?
Because you already knew that.
I knew that they were equal, didn't I?
Yeah.
So I could have just chosen to stop there and know that the other side was going to be the same also. However, by doing that, I did verify that my answer does work to make those sides even. So 45 plus 23 plus 23, 91 pounds. This person is benching 91 pounds. So? With that many muscles, he looks like he could bench more than 91 pounds, though. Just saying. All right. Backside, you try this one. Same exact type of situation. Find X, and then see how much you are lifting. By the way, in this one, the bar weighs different. What does the bar weigh here? 15 pounds. So take that into account for your last step. Okay? So take a minute and work through that one. So how do I get started to solve for X? 4x minus 9 equals what? 2x plus 17. How do I know to set those equal? The weights are loaded evenly on both sides. Okay? So if I want to solve for x, what should I do here? Subtract 2x. Why not subtract 4x? You could, but it keeps it positive if you move the 2x instead. So I have 4x minus 2x is 2x. Have not touched the minus 9, or the equal sign. And over here, what do I have left? 17, right? Because the 2 and the x cancels out. What do I do from here? Add 9. 2x equals what? 26. What's my last step going to be? Divide by 2. X equals what? 13. Okay? Now, how much total am I lifting? Well, I have the weight of the bar. How much is the bar? 15. Plus, do I need to plug this into both of those? No, because I know they're the same thing. So what am I going to choose to do? Plug it into whichever one looks easier. Right? Make it easy on yourself. I'm going to do 2x plus 17. So 2 times 13 plus 17. 2 times 13 is 26 plus 17 would be 43. So that tells me I have 43 pounds on one side. So that means I also have 43 pounds on the other side. Because can you hold a bar like this with the weight on one side being different than the weight on the other? No. Not very well. So 15 plus 43 plus 43, 101. This guy is lifting 101 what? Pounds. And this may seem like a strange request, but please don't use this as your abbreviation for pounds because it looks like a 1. How does that look like a 1? Looks exactly like a 1. Okay, most people do not write that for their ones. Just write pounds, please. Okay. All right, we okay with the weightlifter, guys? Now we're going to get into some geometry examples. Woohoo! Okay, so we have something called a linear pair. You know what the word linear means? That means that here is one angle, right here. And this angle is being called 5x plus 18. I'm sorry, 5x minus 18. And there's another angle here. And this one's being called 4x plus 9. And when you put them together, small angle and big angle, you have a straight line. Okay? What do we know about two angles that make a straight line? Well, we know that a straight line has a degree measure of 180 degrees. So if I have two angles that together make a line, I have two angles that together make 180 degrees. So do you see how they have one angle plus the other angle equals 180 degrees? That's how we're going to find x. Okay? So then it's going to have me substitute the value. So let's see. If I have an angle plus another angle, I really think that we should be putting these in parentheses. It kind of bothers me it's not in parentheses there. Because sometimes if we have a minus sign, that's going to change things, right? Without a minus sign, everything just remains what? The way it is. If it's positive, it stays positive. If it's negative, it stays negative. Because technically, you would be distributing a 1. And 1 doesn't change anything. That's 5x. That's negative 18. That's 4x. That's 9. Equals 180. So I have x's. How am I going to get them together this time? Combine like terms. That means I don't have to do minus 5x minus 5x. They're on the same side, so I just add them together. 5x plus 4x is 9x. These guys are also like terms, so I can just add them. Negative 18 plus 9 is negative 9. Yeah? What am I going to do next? Add 9. So, I'm going to come down here if that's okay. 9x is equal to what? 189. What do I do at this point? Divide by 9. And what does x equal? 189 divided by 9 is 21. So that's the first part. The second part then says what? Substitute the value in to find the measure of each angle. So if I substitute 21 in right here, 5 times 21 minus 18. Well, let's see. 5 times 21 is 105. minus 18 is 87 degrees. We all know to note that is that, correct? Do I need to plug in 21 into here?
No.
I know that together they're going to equal 180, right? So can't I just do 180 minus 87? That means this one right here is 93 degrees. If I wanted to check to make sure my answer was correct, I could plug in 21 over here to verify. 4 times 21 plus 9, there's the 93 degrees. Okay? All right, so that's called a linear pair. I want you to try the next one. It's not a linear pair. These two are called complementary angles. They make a corner. Complementary make a corner, which means that when you add them up, they're going to equal what? 90 degrees. So take a minute, find x, and then tell me what each of those angle measures are. So I have 8x plus 10 equals 90, right? So if I subtract 10, I have 8x equals 80. Divide by 8, and what does x equal? X equals 10. Okay? So if I plug in 10 to here, 2 times 10 plus 15, that's 20 plus 15 means that angle is what? 35 degrees. Do I need to plug 10 in here?
No.
I could just subtract this from what? 90. Or I could plug it in because 6 times 10 is 60 minus 5 is 55 degrees. 55 plus 35, does that equal 90?
Yes.
Yes, so it all checks out all around. Okay? All right, your homework is posted on Google Classroom. You can go ahead and get started on it. Again, the homework looks like a sheet kind of like this, but you can just do your work on a separate piece of paper. That's fine. Okay? Happy studying.